So basically we wrote down the definition for temperature, which says that measure of amount of kinetic energy, the measure of amount of kinetic energy that a substance has at a molecular level. Okay, now basically what we talked about is that when the temperature is high, it's basically it's hot. Okay, now I want to get more into that. Basically that's what everyone knows. Okay, so let's when you study, people should know, you should know more than those people which might just say that when the object is at a high temperature it's just hot. Now here I'll tell you one more thing about those kind of things that you use, you see when the temperature is hot, okay, is that when the temperature is high, okay, now that basically means the atoms are moving faster. Okay, now when you have a temperature which is high, the atoms in that object, okay, what the object is built up of, which is atoms, okay, are moving faster. So atoms in that object are basically moving faster, and those people cannot think of this statement over here, but basically there is not everything that has atoms that will move faster, such as gas or solid objects. So when you have solid objects, okay, solid object, what happens is when the temperature is high, it vibrates faster. Okay, now there's gas. If your substance that you took is gas, then it's basically shooting at each other at a faster rate. So basically, if the gas is the atoms in those gases are shooting each other at a faster rate. Okay, so when you have a gas, it's shooting each other at a faster rate. And you can think of it, this only applies when you have the temperature which is high. Now you can basically restate your statements, which basically says that if you have a temperature which is low, that means the object is cold. Okay, now atoms are moving slower when the temperature is low. Solid vibrates slower. Gas shoots each other at a slower rate when the temperature is low. When the temperature is high, the atoms are moving faster. Solid, it's vibrating faster. Gas is shooting each other at a faster rate. So that's basically it. Okay, now let's go ahead and talk about building the thermometer. Okay, but before talking about building the thermometer, we actually need to know the basics of thermometer before we actually build the thermometer. Okay, now I'm not gonna illustrate you on actually how to. I'm just gonna tell you the simple, easy steps, and if you follow them, you actually make a thermometer out of it. So basically, a thermometer, we're not making a fancy thermometer. We're building a thermometer which scientists made a long ago. Okay. Now this is kind of old thermometer. So this is basically thermometer, and here you have a scale that reads a number, okay, but we don't have the scale yet because we're just building a thermometer. Now what you need to do is you have a copper wire, and you need to wrap that copper wire and put it on the heater or burner or your gas. Now what happens is the copper wire unwraps itself and it becomes some kind of wire, and you put, it's still a copper wire, but it has some energy in it because the temperature is high. So you need to put the copper wire that you got, the final copper wire, after you add heat to it. Okay, so you put it over here and you put the substance. It turns out that you can put two types of substance. One is alcohol and second is mercury. But I would recommend you to put mercury because it's more accurate than alcohol. So here we'll be using mercury because we want to build an accurate thermometer. Okay, and when you do that, it should come up at a random point over here. Okay, now it's a random point. Okay, and what you need to do then is basically heat it. So when you heat it, it should come up the temperature over here, and that is when you add heat. Okay, basically what happens is when you're trying to burn or make the object hot, okay, like a coffee. If you like hot coffee, you're basically adding heat to the coffee to make it hot. Okay, now for those people who like ice cream or cold coffees, what happens is that you have the temperature and you need to put it into your refrigerator, and we'll show some temperature over here, which basically means that you're subtracting it. Now, let me just tell you the reason why we can't say what we can say that add cold. Because it's basically, well, now you can't say this, you cannot say add cold because it sounds wrong, and because when you pull the melted ice cream, which has some kind of heat to it, okay, melted ice cream into refrigerator, what you're doing is not adding cold to it, you're basically subtracting heat from it, okay? So when you subtract the heat from it, what happens is that it becomes solid again, okay? It becomes frozen ice cream again, and you can enjoy eating the ice cream. So basically what you're doing is when you have the frozen ice cream and you put it at the room temperature, you're basically adding heat to it, because in the freezer it's basically colder than it's in what the temperature is in the room. Now when you take it out from your refrigerator, you're basically adding heat, and this is the concept everyone gets. Now this concept over here, when it's all melted, now if you put it back, for those people who doesn't like to eat melted ice cream, so what they do is put the ice cream back into the refrigerator, and basically what they're doing is, since the heat is already being added to the ice cream, well, the freezer needs to subtract the heat from it, so it becomes frozen again. Now I hope everyone has understood this. So we cannot say add cold to it, because it's wrong. Okay, now up till now we talked about building the thermometer. Now let's say if you want to construct the proper scale, okay, just basically what I told you is wrap the coil and put it on the burner. It unwraps itself automatically. Then you need to put that copper wire over here in this kind of container, and you add mercury to it. Now the thing here is what we were going to talk about is basically calculating the scale. Okay, you have seen the actual thermometer which reads the scale. Now how do we construct that scale? Here's how you do it. Okay, let me just erase this. Okay, I'm actually running out of time, so you guys watch my next video which talks about it. Thank you.